Today we're going to solve systems of linear equations by elimination, but I need to set it up first. I want to show you some things that are going to make what we're going to do make more sense. I don't want to just show you steps to do and they're meaningless to you. You don't know why you're doing them. First thing we need to do, we need to define terms because that's something we're going to talk about. The definition of terms is things separated by plus or minus. And really, we can include the equal sign too, because the equal sign definitely splits things up. But the true definition is things separated by plus or minus. Okay, so with that in mind, I want to show you some math phenomena that are that this is always true, this always happens, and it will help us to understand why we're going to do the things that we're going to do. So let's take a true statement. An equation is a true math statement. What I want to show you here is that, okay, first of all, how many terms do we have? Well, there's 1, 2, 3. There's 3 things in here because they are things separated by plus or an equal sign in here. So we have 3 terms in this equation. I can choose to multiply every term in an equation by any number I choose. So let's try it. Let's multiply every term in here by 2. 2 times 4 is 8. 2 times 8 is 16. 2 times 12 is 24. Do we get another true statement? Well, yes, we do. 8 plus 16 is 24. Okay, so and that always happens. I'm not going to prove it, but remember, you can multiply every term in an equation by any number you choose, as long as you do it to every term, which means we're doing it to both sides. Okay, can I choose to divide every term by whatever I choose? Well, let's try it. Let's divide everything by 4. 8 divided by 4 is 2, 16 divided by 4 is 4, 24 divided by 4 is 6. Do I get another true statement? Yes, I do. Okay, the moral is you can always take any equation in the world and you can choose to multiply every term by any number you want, or you can divide every term by any number you want, and everything is okay. You will, if you started with a true statement, you will end up with truth after doing those 2 things. So it's always okay to do that. Now I want to show you another thing. Can I add a couple of true statements? So let's take something we know is true. This is a true statement. Let's add it to this one. 8 plus 16 equals 24. Okay, let's add these up and see if we get another true statement. So 8 plus 4, 16 and 8, 12 and 24. Yeah, so I'm adding up vertically, and sure enough, we do get another true statement. Okay, could I subtract true statements? Well, let's take 4 plus 8 equals 12, and 8 plus 16 equals 24. These are 2 true statements. Now I'm going to subtract them. 4 minus 8, negative 4. 8 minus 16, negative 8. 12 minus 24 is negative 12. Is this a true statement? Is negative 4 minus 8 equal to negative 12? Yes, it is. Okay, so what I want you to remember is you can take any equation in the world and you multiply or divide every term by any number you choose, and it's okay. You can also add any 2 equations or subtract any 2 equations, and that is okay. Okay, now let's solve a system using these principles. So I have 2 equations here. They both have an x and a y, and whenever you're solving a system, here's what you're looking for. If you were to graph both of these, you'd have a couple of lines. So I don't know what the lines look like. I'm just making an example here. But okay, so say one of these is this line, one of these is the other, and you're looking for the point where you have the same XY pair that you could plug the same X and the same Y into both of these and it will make them simultaneously true. Okay, so That's what we're looking for. Whenever you solve a system of equations, you're looking for an ordered pair. You're looking for some XY ordered pair that you could plug it in to both equations and they would both be true. If only one's true, it is not a solution. They both have to be true. Okay. Um, I did another video already on solving these by substitution, but today we're going to do solving by elimination. It's a different thing, different method, but it will get the same thing done. And sometimes one is more convenient than the other, and sometimes the other one is. Okay, here's what we're going to do with this. I know that I can add or subtract these together, and I will get another true statement. Well, I want something that only has x's or only y's in it because I can't pin down x and y if you think about it. If I take this equation and I make x 1, well, that's going to make y have to be something in order to equal 2. If I change x to 2, that's going to make y change in order to equal 2. You could do that for all eternity. You could come up with xy pairs that would make this true, but they wouldn't necessarily make this true. Well, I'm looking for the XY pair that will make both of these true, but I have no way to solve if I have two unknowns. I have to finagle this where I have an equation that has only X's or only Y's. And that is what we're going to use the principles we just saw to do. Okay, well, let's think about it. What if I were to add both of these? So I would have X plus X, I would have 2X. So remember, we're adding. That's what you want to, you have to decide whether you're going to add or subtract, and then don't forget which one you're doing. So we have to do this column, and this column the same way. They have to add. What if I add negative y to positive y? Or you could think of it, y plus negative y, which is the same as y minus y if you think about it a little bit. I'm not going to go into depth on explaining this, but if you think about it, I think you'll see if you combine a y and a negative y, you get 0, just like y minus y is 0. Okay, well, I'm adding a negative y and a positive y. That is going to give me 0. Okay, well, I have to add this 2. If I add a 2 to a negative 4, 2 plus negative 4 is the same as 2 minus 4, and that's going to be negative 2. Okay, let's look at the advantage here. So I'm going to write this without that 0. Obviously, we don't need to write that. Well, now guess what? I have eliminated the y variable. I have only an x, which means I can actually pin down a specific value of x. And the way I'm going to do that is, as you probably know, divide both sides by the number in front of the x. It's multiplying it. And we get x equals negative 1. We now know the x part of this ordered pair, but we don't have the y yet. Well, once you get one, it's easy to get the other. So in this case, I got an x. Now I can go back to either one of these. It doesn't matter which one you use because we're finding the point where they're both equal anyway. So pick the one that seems like less work. So I'll just use the top one here. So if we now know x is negative 1, then we can say negative 1 minus y equals 2. So all I did was take this and rewrite it, but now since I know x is negative 1, I put that in there. Now we can solve for y. Okay, so I'm going to add 1 to both sides, and so I get negative y equals 3. And if I multiply both sides by negative 1, okay, and we just saw you can do that. I can choose to multiply both sides by whatever I want. Well, negative 1 times negative y is positive y. Negative 1 times positive 3 is negative 3. And we now have the other part of our ordered. Now, I'm not going to take time to prove it. This is our answer here. But you can test it yourself. You can take the negative 1 and plug in for both the x's here and take the negative 3, plug it in for both the y's, and you will see it makes the top equation true and the bottom equation true also. But now I want you to see something else. I'm going to make some room here. Okay, so I made some room. I have written the same exact thing over here, but I want to show you that we could also choose to subtract one from the other. So I'm going to subtract the bottom from the top. Here I added every term, all the columns. Okay, what if I take this x minus this x? Well, that gives me 0. Now I take negative y minus this y. Okay, well, think of negative y minus y is negative 2y. So this is negative 2y. And now 2 minus minus 4. So 2 minus minus 4 equals 2 plus 4. I'm not going to go into it, but a negative negative, subtracting a negative is the same as adding. So this is actually equal to 6. Okay, let's just ignore the 0, and let's just think about this part. So here I've eliminated the x variable. So when I added, I eliminated the y variable. Here, when I subtracted, I eliminated the x variable, and it allowed me to figure out what y is. So if I if I divide by negative 2, negative 2 over negative 2 just equals 1. 1y is the same as y. Okay, positive divided by negative, 6 divided by 2, negative 3. Okay, so if we hadn't done it this way, we could have got the same thing done by subtracting. And so we got the same y value here by doing that. Now, I'm not going to do it to save time, but you could take your y back and plug it into either one of these and see what x is, and you would figure out that x is negative 1. So I wanted to give you an example of adding two equations or subtracting two equations. In this case, they both work. Now, they don't always work. Sometimes you have to decide carefully, is it better to add or to subtract? In this case, if I want one of the variables to go away so I can solve for the other one. Okay, let's do another one. Okay, so looking at this one, I'm not going to be able to either add or subtract both. There's only going to be one that's going to do what I want it to do here. So let's think about it. Which variable am I going to eliminate? Well, here I have a 2 in front of each of the y's. So this is the one I'm going to eliminate. The x's are going to stay. There. When I subtract this, I'll get an x term. I'll get a 0y term. Of course, I'll get a constant over here. And so we want to eliminate the y. So this is where we ask ourselves, if I add these terms, am I going to get 0? Or if I subtract them, am I going to get 0? Well, we need to add, because if you have 2y minus 2y, so really when we combine like terms, we're just looking at the numbers in front, the coefficients. So we know that we need to combine the 2 and the negative 2. Well, if we add 2 minus 2, that's going to be 0. So we're going to get 0y, and that's what we want. If I had subtracted, it may look like we're subtracting here. But if I do 2 minus negative, I'm not subtracting 2, I'm subtracting negative 2 if I do that. I'm doing 2 minus negative 2. Well, that's 2 plus 2, which is 4. So you have to be pretty careful picking whether you're going to add or subtract. Okay, the thing that's going to help us here is to add if I want to eliminate the y terms. So we're going to add all the columns. 2x's plus 3x's is 5x's. 2y plus negative 2y equals 0. 12 plus negative 2 is the same as 12 minus 2. That's 10. And so I'll just rewrite it without the 0. And normally I wouldn't even put a 0 here. I wouldn't put anything. I would just put the 5x and equals 10. Okay, well now we can figure out x, and x equals 2. We now know the x part of the point where these two will cross, or if they were on a graph, or you could say we know the x coordinate of this ordered pair. We still need to find the y, and when we do, we're going to find the x and y that we could plug into both of these, and it would make this one true and this one true. Well, okay, now I already have x, so I don't need to work this hard to get y. All I need to do is go back here. I can pick either this one or this one to plug x into and solve for y. It doesn't matter because since we're looking for the point of equality, if I plug this 2 into here or here and solve for y, it will give me the same y. So pick the one that seems like it's less work. I don't really see where either one of these is less work. So I'm just going to take the top one, and x I now know is 2. So I'm just going to put that there. And I'm just writing the same thing, but now I put in for x what I know x is. So that's going to give me 4 plus 2y equals negative 2. If I subtract 4 from both sides, this is now 0. I get 2y equals negative 6. And if I divide both sides by 2, I get that y equals, okay, so this is just a 1. That's what cancellation is turning things into 1, not 0. So y is negative 3. Okay, and so this is our answer. We have figured out the point that is the xy pair that would make these. If we took this x and we plugged it in here for the x's, and we took this point, sorry, this coordinate, this y value, and plugged it in here. Okay, I'm not going to do it, but you can test, see if I'm telling you right. Okay, if you go ahead and do this, see, this would be 4, and then negative 6, 4 minus 6 is negative 2. This would be 6, positive 6. 6 plus 6 is 12. So yeah, it makes them both true. There, I said I wasn't going to do it, and I did it anyway. Okay, but that's the proof that this system works. It finds the point of equality. Let's do another one. Okay, on this one, I don't have the same number in front of either both the x's or both the y's, so I'm not set up to eliminate them, but that's where we can use the principles we saw at the first part of this video, and we can maneuver things so that we create the same number in both in front of either both the y's or both the x's. So here's what I'm going to do. In this case, I have a 1x and a 3x. If that was a 3, I could eliminate the x's. So here's what I'm going to do. I am going to multiply this equation by 3 because we saw that earlier. I can choose to multiply every term, there's 3 terms in this particular case, by any number I want. So I'm going to do that. And so here's what we're going to do. This top one I'm going to copy over here just like it is. I'm going to leave it alone. But this one I'm going to multiply every term by 3. So 3 times x, 3 times, so this would be a positive times a negative, 3 times 5 times y, and then 3 times 17 would be 51. Okay, and now I have maneuvered this so I can do what I wanted to do. I can use either addition or subtraction to eliminate one of the variables. Well, I now have a 3 in front of both x's. So if the signs were different, it would affect whether I added or subtracted everything in here. Well, since they're the same, I'm going to need to subtract, because obviously if I add these, I'm going to get 6x, and the x term is not going to go away. So I need to do subtraction all the way through here. 3x minus 3x is 0. I'm not going to write anything here now because, I normally wouldn't. There's nothing there anymore. Okay, now I'm doing 2 minus 15. So that is 2 plus 15, which is 17y. And now if I do 0 minus 51, 0 minus 51 is just minus 51. Okay, and now I solve for y, and y equals negative 3. Okay, I now know the y part of my solution. It's negative 3. So both of these y's here in the original blue, not the yellow here, but just the original blue. Let me get this off of here. Okay, so I can figure out the x now real easily by taking this negative 3 and either plugging it in here or plugging it in here. So it looks like it might be easier to plug in for this one, so I'll just plug it in there, and then that's going to give me negative 6. Okay, so this here gives me 3x minus 6 equals 0. So if I add 6 to both sides, I get 3x equals 6. I divide both sides by 3, and I get x equals 2. And now we know the full point, okay, the ordered pair, the point 2, negative 3. If you plug in the x's and plug in the y's, you will get equality for both of this. This is the solution for both of them, and we've done what we wanted to do. Okay, on this one, you'll notice there's really nothing I can multiply through by some integer to get the same number in front of x or y down here, either one, because 7 and 4 don't have any common factors, and 8 and 9 don't have any common factors. So here we'll have to do something else that, it's not really that much more work, but here's what I'm going to do. I'm going to multiply this top equation through by 4, and I'm going to multiply this bottom equation through by 7. Where did I get the 7? Well, I got it from here, and I got the 4 from here. What do you think is going to happen when I do this multiplication right here and here? Well, it's going to give me the same number in front of my x. So let's go ahead and do that down here. So this, well, actually, I'll do it. Let's do it over here. Okay, so negative times a negative, 4 times 7. Okay, positive times a negative, 4 times 8. And then 4 times 9. Okay, let's do this one. So again, I'm going to get negative 28 because that's how I set it up. I forced that to happen. But I have to multiply every term. So 7 times 9, 63y. This is going to be positive times a negative. 7 times 22 is going to be 154. Okay, we're all set. So what do you think I'm going to do here to eliminate the x? Am I going to add or am I going to subtract? Well, if they're exactly the same in every way, including the sign, you need to subtract, which means I need to subtract all of these. Well, what's negative 28x minus 28x? So let's think about that. Negative 28x minus 28x is the same as this. And what's 28x minus 28x? Oh, it's 0. So negative 28x minus 28x is 0. I'm not going to write anything here because there's nothing here anymore. Okay, but now since I subtracted here, I have to subtract everywhere. So negative 32 minus 63, that's going to be negative 95. And I'm just combining like terms. So if I have negative 32y's and I take away 63 more y's, I'm going to have negative 95 y's. And then if I do 36 minus 154, that's 36 plus 154, that's 90. Okay, we're almost there. Divide both sides by 95. This just turns into a 1y, which is just a y. And we now know if we do the division here, we get negative 2. And so for our ordered pair, we now know this part of our answer. Okay, this is the answer, but we don't have the x part yet. So that's where you come back to your original equations and pick either one. Doesn't matter. We now know y is negative 2. And so if you put that in there, and to save time, I'm not going to do it. I'm just doing the, I'm not looking at this part now. I'm just looking at the original equation. And if you do it, you will get that x is 1. And so now we know that the xy combination that would make both of these true if you plugged them in is 1 for x and -2 for y. This video has gone kind of long, so I'm not going to go into depth on this last thing, but I want a parting word. Uh, uh, so far, the examples we have seen here do have an answer. There are three things that can happen when you are solving for two equations. Remember, every equation makes a line on a graph. Okay, so each equation could produce lines on the graph that cross, in which case we're looking for that point, that xy point where both the same x's and y's make them both true at that point. Well, every example we did was that way, but there are two other things that could happen, and I talk about this more specifically in my other video where we're solving systems by substitution rather than elimination. Two other things that could happen, well, the two lines could be parallel. Okay, when the two lines are parallel and you try to do the process that we just did, that we've done all through this video, you will not find any solutions. So the answer here will be no solution. How do you know if there's no solution? Well, when you try to do the process, you're going to get some absurd statements. You might get, 5 equals -2. And if you didn't do anything wrong and that happens, there's no solution. You're going to get nothing but chaos. Okay, that's how you know when there's no solution, is when you get some stupid, absurd statement that doesn't make any sense. There's one more thing that can happen, and that's where you have, your two equations make a line on a graph and the other one goes right over the top of it. In other words, they may not look like it because maybe stuff's moved around and they're not in the same form or the same format, but what you'll realize is that, hey, these are actually the same equation. And so if they're the same equation, you're going to have infinite solutions. And that just makes sense, because if both equations are really the same, then every point that works for one is going to work for the other because they're the same. How do you know, when you do the process we did in this video, how do you know that this is what's happening? Well, because you'll find that no matter what you do, you're going to get stuff like this, or you're going to get a bunch of stuff that no matter what you do, according to what you do, different things could happen. But when you see that you can't avoid equality, that everything you get on the left is equal to everything on the right, you know that this is what's happening. They're really the same equation. And so you can't get an inequality. You can't get an untruth, mathematically speaking. And that is how you know that it's infinite solutions. So if you have this, you get infinite solutions. You get an absurd statement, you know that you have parallel lines they can never touch. So obviously there can never be an XY pair that they have in common. Or if everything goes normal, then you know they're just a couple of lines that cross, and there's going to be one XY pair that works for both of them. Hope this helps.